There you go.
Yes, okay. So our next speaker is Matthew from Microsoft Research, and he's going to be talking about C# taint analysis and augmenting static analysis with the large language model. So yeah, Matthew, the stage is yours.
Great. Thank you so much for having me. So I'll be talking to you about the work I've been doing over the past few years on the project I call INFER'23, and how it's sort of been shaped by some of the trends that have happened in the past year and where we're going to go forward with it. Give you a bit of background about myself. I started some years ago in 2019 as a slightly less than fresh grad out of my bachelor's working at Microsoft on a science team, purely focused on AI-based tools. And I mean the kind of AI which is artificial intelligence, not abstract interpretation. Basically, my manager tasked me with the simple task of architecting from scratch a bug patching platform. And of course, this kind of thing would have to be able to work at Microsoft scale. In any case, I started with the detection component and tried to figure out what kinds of tools were available that have actually been successfully deployed at enterprise scale, meaning things like it's adequately useful for developers in terms of precision, as well as actually runs fast enough for them to see it in a relevant way. So this brought me to Infer. And I felt a lot of conviction that this is sort of a tool that would add a lot of value in terms of being able to secure and improve the performance of the whole suite of products and developer customers that Microsoft serves. But of course, I'd have to run out of C# code to convince anyone else about my conviction, which is why I built a frontend, which we call INFER'23. So we ended up open sourcing it. We just this past year presented at .NET Conf 2022. But here are a few metrics that summarize some of the progress in terms of the adoption. But actually, this talk is less focused on that aspect and more on some of the new trends of 2023 that have already shaped and continue to shape the future of this effort. Basically, I hope there are three things that I hope you take away from this talk. One is, what does Microsoft want to do in its vision of security, and what does its sort of internal engineering system organization, what's its vision, and where does Infer fit into that vision? I want to walk you through some of the challenges and the process of trying to make Taint work for INFER'23, and which has been sort of critical work towards moving towards this vision. And also, I'll touch a little bit on AI, the non-abstract one, and Infer. All right, so to give you a bit of context, security is a huge issue for Microsoft. In 2021, Biden signed an executive order on improving the nation's cybersecurity. In particular, they have a clause on improving software supply chain security. I'll read you a bit of context for those of you who aren't familiar with what I'm referring to. Basically, it says the EO will improve the security of software by establishing baseline security standards for development of software sold to the government, including requiring developers to maintain greater visibility into their software and making security data publicly available. It also creates a pilot program to create a Energy Star type of label so that the government and the public at large can quickly determine whether software is actually developed securely. This is why there's a whole significant effort at Microsoft to try to find the cutting edge tools that will be able to, for example, certify that the packages we use internally and that we ship to customers are secure. There's a whole project called GitHub Advanced Security. It's a large effort. Its whole charter is to offer through GitHub a suite of technological solutions for identifying source code issues, but there's a huge gap. Currently, it uses a tool called CodeQL. it's really focused on security bugs. And to date, it's actually Microsoft's answer to this executive order. And now, it sits outside of the developer workflow because it's too slow, basically. It goes back to what I was saying in the beginning, which is that I think the Meta team has done an incredible amount of research to take care of the fact that no one's going to be able to use a tool if it's too slow and cannot be deployed when the code is fresh for developers. And the way CodeQL works is that it delivers these offline bug reports to developers for periodic runs on the whole code base, which I think everyone in this audience will know can agree with at least. This would give quite a low response rate. But this kind of fault actually gives us on Infer a huge opportunity, because Pulse's taint analysis actually can cover that gap, identifying a huge source of these kinds of source sync security issues in code at PR time. To just touch on this point a little bit more, the security rule enforcement team here even has one of the biggest issues that they're trying to figure out right now is, well, we have such a low response rate from this offline deployment. So that's sort of the context for where I see Infer fitting into that vision. Now, so now I'm going to sort of explain the process and learnings along the way of trying to get Taint working for .NET. While much of the content is actually specific to C#, I'm hoping that other people who are trying to write other front-end developers, they may be able to generalize some of at least the debugging process for when you run into puzzling results, or particularly if you're working with, asynchronicity, which is a topic I'll definitely be addressing shortly. So, but basically, here's sort of the problem. So after turning on Pulse, the taint analysis in Pulse and adding a few of the sources and sinks, I could actually get it to successfully find issues on simple benchmark examples. The problem, and I focused on SQL injection specifically because apparently that is one of the top issues that people care about, is that I couldn't find, in millions of lines of code, it wasn't able to find a single SQL injection error. Now, the problem for me is, I don't know whether it's just that Infer is very precise, or is it that we just have an issue in maybe my code in the front end, or maybe in the back end code of Infer. So what I did was, I benchmarked against these flows identified by CodeQL, which are actually legitimate, and could actually verify that Infer something is going wrong on the Infer side. Well, so I'll break down this sort of problem solving into three sort of different areas, all of which were kind of critical to trying to tackle this problem. One is, well, there is a huge sort of, well, seemingly not huge, but actually quite substantial gap in the actual translation coverage. So we only translated, prior to this year, we only translated about 90% of methods. And the problem is that that had a disproportionately vast impact on the recall of issues that Infer is able to detect, and I'll touch on that a bit more shortly. Second is there's this asynchronicity in C# turns out to be quite a significant issue because while it's commonly used in C# and C# makes it very easy for developers to use, it creates a whole lot of syntax in the back end that confuses Infer actually, if I just apply a standard approach to the translation. And finally, actually, there are also some issues we ran into where the backend analysis literally just times out because. So I'll sort of break down this part of the talk into three different components here. But the first one is translation coverage. So having we had quite limited support for exceptional control flow because, well, in the initial version, we essentially assumed that there wasn't going to be vast levels of, or even multiple levels of nesting in the control flow when it comes to the try catch, try finally. And this actually disproportionately affected recall of resource leaks and taint because, as you can imagine, code that utilizes disposable resources that you need to actually free are going to disproportionately use the using construct, or the Java equivalent would be try with, which is actually just the try finally at the end of the day. And Taint similarly, the kinds of resources that you need to the kinds of resources that are involved with taint errors tend also to be these kinds of resources that need to get freed. I'll touch on that one a bit as well. Which is why this 10% didn't sound like a big gap, but it actually was a huge issue. And to quantify that, well, we saw 2 to 3 times as many resource leaks on the same exact code base after going from 90% to 99%, covering that exceptional control flow as well as some other instructions. The funny part was still no SQL injection errors. So, I was in a place where we were able to find a lot of more resource leaks, and also some more false positives as well, though, concerningly enough. But no SQL injection errors. So that, but one key observation I made along the way is, well, hey, I mean, you have these, essentially these examples, if you look at what INFER is actually rendering, it's translating this async method. And if you look at what the bytecode is rendering at the bytecode level, is that the async method keyword takes what would look like a regular method and maps it actually to a whole class that represents a state machine, essentially. And infer, if I just do it, handle these kinds of methods the same way that I would handle a regular method, well, infer actually doesn't understand that at all. So, and that's where I soon would realize the false positives on the resource leak end were, as well as some of the false negatives when it came to this taint analysis was. So to give you a bit of perspective on this, let's just say we have a simple hello world. All we do is literally write hello world to the console. As you can see here, it's about 5 instructions. As soon as you add, the only difference between that and this here is we added async on the left, and suddenly, as you see on the right, the same method is, I don't know how many lines that is. That's actually only part of the what the compiler generates on the back end, because it generates a whole class, and this is only one method within the class. So you can kind of get a picture of why there's a bit of why Infer will get stuck here. And there are a lot of differences that sort of need to be carefully handled in order to properly make this, or to considered in order to make this properly work. So, and I won't drag you through all of the sort of minutia of that. I've listed them here for those of you who are curious, but a few that I'll call out. The main one is that the original method M actually gets stored in a move next method within a new M class, essentially, the state machine class. And the move next method actually has a void return type, and the output of the method instead is stored by an unmodeled set result method. Now, the problem is that, and why we're getting all these false positive resource leaks is, well, when we allocated resources in this asynchronous method and returned that resource, this set result method is not modeled, so infer is going to reason that the resource is no longer reachable. So And hence it'll just report that it's leaked, even though it's in fact still remaining in context because it's returned. So the essence of this problem, though, is that Infer wasn't properly interpreting the semantic behavior of M because its true context had been moved to this new method, m.moveNext, which the compiler is processing within this state machine context. So the solution is essentially just making the simple observation that the asynchronicity, for the purposes of the kinds of bugs that Infer discovers, like nullity references or this taint issue or resource leaks, the asynchronicity aspect can actually essentially be ignored. So what I did was is hack the front end translation of m.moveNext so that the input and output information flow kind of looked like the regular method m. And then I just also renamed m.moveNext to m wherever it occurred. And the extra, and like that, the as I expected, the false positive resource disappeared, and now some legitimate taint errors were now starting to appear. Okay, so this brings us to sort of the last and kind of ongoing issue that I'm working through, is that the remaining false negatives kind of seem to occur when the backend times out. So basically, we could find SQL injections on a small subset of a project, but if you ran the analysis on the whole project, say, or even increment, this is independent of incremental analysis, by the way. But if you analyze the whole project, SQL injection gets missed. This has to do with how Infer handles the maximum amount of disjunct and how it discards information. So hopefully with some work from on the back end later to sort of represent the domain in a different way later this year, these issues will sort of resolve themselves. In addition, to mitigate this, I've been also toying with some of the parameters like timeout and max disjuncts as a kind of mitigating solution. But anyway, just to wrap up this sort of discussion, this is where the project is going over the next 6 months. So right now we're in the process of running Infer' on Microsoft's internal engineering system teams' code bases. So there are two main objectives here with this effort. One is continue to improve this front end, this pulse taint, based on the findings, sort of per the sort of work that I just showed you. And also, another is driving internal alignment around the capabilities of Pulse, because this is kind of this is a technology that is alternative to what Microsoft has already signed up for. It's signed up for what I believe to be a product that I believe leaves gaps in the security offerings. So part of the work is also proving out the capability and being able to show, hey, this tool actually will add incremental value over what we have today when it comes to securing our code bases early. So there are two on a broader level, though. There are two broader objectives. One is making Infer and Infer' a security accreditation component within Microsoft's software supply chain security roadmap. You know, again, that's the sort of effort to try to that's Microsoft's effort to try to develop a pipeline that's actually going to be able to justify to the government, help them justify to the government that they've done due diligence when it comes to securing developers from security issues. And second is integrating Infer into as a native part of GitHub Advanced Security's PR Time code scanning offering. And now, of course, as you know, Microsoft has AI seems to be all that AI is all you need to say in an earnings call these days to raise your stock. So that's what we're going to do here now. We're going to add some AI to Infer's abstract interpretation. But jokes aside, there are, I think, a couple potential areas where some of the energy in LLMs can add value to the Infer story. One is, can we enhance warning reports with additional context, particularly for some of these more complex issues? For example, if you're a newer developer who may not necessarily understand all of the nuances behind code safety violation or a resource leak, well, can we give a bit of context there to help them understand it and potentially prevent them from adding such issues in the future? And additionally, can we generate and recommend the appropriate fixes for the warnings? So recently, we put together a bit of a demo which actually uses Infer and ChatGPT essentially in one PR time experience that I'm playing for you here in the demo. So as you can see here, this is we have a taint issue. And actually, if you actually pass the what we call the serif generated by Infer, that serif is Microsoft's kind of static analysis general. It's essentially a JSON that follows a certain format. It's owned by Microsoft, but essentially giving the LLM the serif and telling it, hey, can you sort of explain what's going on here? You can actually get it to articulate some of the ideas, as you can see in that initial comment. Moreover, it's actually quite trivial to extend this feature so that you can, for example, talk back to it and ask it to contextually explain what's going on. So for here, for example, if you didn't know what taint was, it's fairly trivial for you to just ask it. Again, this is kind of ironically some of the easiest work in the entire project, but one might argue it's the more flashy part. But so, like, here's another example. So, of course, this is a resource leak. The magic is actually primarily Infer because it's able to figure out that there's an interprocedurally returned secure string object, and that can lead to. But the cool, kind of neat thing here that I want to call your attention to is that the secure string object is not just, it doesn't have the same implication as just, say, a stream reader or some other reader object. It actually poses a security risk, and the LLM actually can explain that to you in a way that if you just see, oh, this is a resource leak warning, you wouldn't get that context. It's also pretty easy to get it to suggest the appropriate fits and easy to hack the UI so that it, you can automatically accept those things. Again, this is just, you guys have all seen this. It's a thread safety violation. Same deal. You can, there's this explanation and that is potentially more readable than the kind of, if you just go to a CWE MITRE website to try to learn about this. And if you talk, and the last thing I wanted to call your attention to is actually, since it is a large language model, you can even do things like get it to translate all the stuff it's doing for you. Anyway, this is sort of the main part of the demo that I wanted to show you. But all in all, all in all, that was essentially the deck I had for you today. And the short and the sort of takeaway I hope you guys all take is that I think there's a whole lot of opportunity for us to, particularly with how AI has shaped our past, how AI has shaped the whole world in the past year. And I think we can build some quite interesting and useful products on top of Infer as a result of it. Now, the irony being that all the hard work is actually done by Infer on the back end, and so all of the hard work will continue to be, really getting this tool to work as well as possible. Anyway, that's all I had. Thank you so much.
Thank you for the nice presentation. Can you still hear us, just to verify?
Yes. Yeah.
Okay, great. So yeah, thanks for the talk. It was very, very interesting. Any questions from the room?
Hi, Matthew. Thanks for your talk. I'm David Pichardi. I have a question. Related to exceptions and exceptional edges.
Yes.
As far as I understand, you perform the taint analysis and the resource analysis at the same time, or you let Pulse do that. Yes. And
we
use Pulse. We use Pulse.
Yes, you use Pulse.
Yeah.
But correct me if I'm wrong, but I think when you look for taints, for example, in this case study that you mentioned, it is likely that if there are bugs, they will not necessarily follow exceptional edges. So I will have tried to just forget about exceptional edges to perform taint analysis. You will have less timeout from Pulse because you have less visions.
Okay.
And it's a strong under approximation, but okay, I think if there are bugs, tainting, if there are privacy bugs in your code, they are likely to not follow exceptional edges. You see my point?
Yes. Thank you. Yes, that's a really useful tip. Thank you.
Well, on the other side, it's true that for resource analysis, what we want is to follow these edges because these are the source of all the bugs. So they are quite different analysis indeed.
Yes.
And my second question was related to AI, LLM.
Yes.
As far as I understand, you propose to use AI to make a better signal for the programmer to explain things to him. But I'm not sure to understand if you want to also provide some repair to.
Yes.
Okay.
Exactly. That was part of. That was exactly what let me bring you back to the thing. So that was exactly what I was showing in the. Let me see.
Yeah, but so were you able to do that? Is it already done? It is a part where I'm a bit confused. Were you able to make the AI suggest code?
Yes. Sorry. This is let me give you a bit of that context here again. Oh, sorry. Are you able to see? You can see my screen, right?
No. We have to maybe click on something. We will see.
Is there a delay? I'm trying to play you the demo again.
Yeah.
Because this is the kind of demo that, are you able to see? I just want to check to make sure the demo actually is playing where I think it is. Is it working?
No, we cannot see it. But it's on our side. On our side, we need to find the right button, but there are plenty of them. No, but explain like that. Yes, just.
Yeah. So actually, this is what I thought was quite interesting, is because I know that you had the Getafix project at a few years ago. So I started some initial work on that because I was trying to do repairs, but in some sense with the ChatGPT, I noticed that particularly for things like resource leaks, null dereferences, and also thread safety, these issues, at least qualitatively speaking, they're quite, the ChatGPT is quite competent. If you give it just the method context, essentially, the context of the containing method, as well as some serif file output by infer, so that it says, hey, here's the bug, and here's exactly the flow that resulted in the bug, essentially, and then you give it the method context. ChatGPT is able to synthesize quite a believable fix in a lot of different scenarios. And in some sense, it's going to be a lot simpler than just, say, calling getAfix, or the hierarchical clustering whole pipeline. Obviously, hierarchical clustering can probably be done on a CPU, so there is a cost question to be considered here. But I thought the actual outputs of the LLM was quite impressive for the fixing aspect.
I see. So myself with the AI team at Meta in Paris, the FAIR team, we did a little experiments where we try to train the model using INFER, in the sense that the repair that will be suggested by the model will have been double-checked using INFER, so that we hope the model will always propose a repair that is at least compliant with INFER.
Yes.
Okay. It's right. A guarantee, but not a strong guarantee. Yes. So that's why I was curious, but it was it was more research approach, and there is no tool available. But it seems that you were able to already get something interesting and useful just using available LLM.
Yeah.
Okay.
Yes, that's interesting. I actually was surprised by the results, because usually you'd expect, it may not be able to explain, for example, or even insert. We've all seen code. If you've tried Copilot, for example, it'll not always even insert code that compiles. But at least when you give it sort of the very detailed information that Infer can provide, it seems to be able to piece things together quite well in this constrained context. And I do want to comment a little bit more on this, which is that I have also experimented with, for example, using a CodeQL trace in a serif. And actually, the thing that makes Infer work well with this particular thing is that it has kind of concise and well articulated descriptions of the warnings, and also the so that basically the LLM can parse and produce the right output. Whereas if I gave it CodeQL, actually some of the CodeQL serifs are so long that the ChatGPT just crashes from the get-go. So I just want to point out that Infer is also really useful because it produces well formulated answers.
Yeah, I see.
By the way, in the meantime, we could get your screen back, so now we can see your screen again. So if you want to show something, sure. We can see it now. And I see two questions on Discord. Maybe I will start with the second one, because it's +1 on the current question. How advanced and accurate is the AI contextual explanation capability?
I think honestly that so I don't have numbers for you right now, but from sort of my experimentation over the past couple months, qualitatively, I feel that it's quite strong. So, and I'm giving you examples where, while they are like not too complicated, like they are kind of simple examples. They are not. What really is the magic here is what Infer has done, right? So it can really clearly explain, the taint starts from the parameter that occurs on line blah in this method, and then if you give it all the flow information, and then ChatGPT essentially can colloquially explain that for the taint aspect. But when it comes to something like a resource leak, essentially, or a multi-pointer dereference, it can do the same thing. So you can kind of see that it's really not, the AI is not doing anything too, like it's not creating like something too groundbreaking out of nothing. It's really, the magic happens because Infer is able to provide a very detailed and well-articulated trace.
So basically the other AI.
Yeah, the other AI. The AI,
yeah.
yes.
Thank
exactly.
you. So another question by Radu, our previous speaker. Do you use any dynamic analysis for C#, especially for taint and leaks?
So I haven't touched on that yet myself. I am interested in the opportunities in that space. There is some other work on my team that utilizes dynamic traces and dynamic analysis. But you know, if anyone has thoughts on that or how it can be used to augment some of the results from Infer, I'd love to hear.
Yes, so Radu also has an observation that we also noticed false negatives for taint stuff caused by backend timeouts, and Radu basically added like a new command line option, --pulse force continue to help a bit with that. You can check out the documentation of Infer. And note that it may add false positives. I mean, I'm just reading out what's on Discord, so you can find it there.
I actually, quickly respond. I actually, I had a conversation with Jules about this. I tried the false force continue on that, and that's where, so I had 0 disjuncts essentially, which is why the analysis just got killed. Before I added it. After I added it, I had like 20 disjuncts, which is where the pulse timed out. So that's sort of the where I ended up. What I was referring to when I said that one of the main issues outstanding is sort of this pulse timeout thing. That was actually after I tried the pulse force continue.
Yeah. So just one further remark, like coming back to the topic of dynamic analysis, basically we are also experimenting with that on the WhatsApp side. We just gave a presentation recently at ICSI on how we are trying to combine static analysis, or like how we try to augment static analysis with dynamic data. And it was just a presentation, so I'm not sure, and I don't think it has been recorded, but I can share the slides with you, or we can talk about it. But in short, the idea is that we have many cases where Infer or Pulse fails to analyze a function. Maybe it's because it's complicated or it's some library function, and then we will have an empty summary. And if another function calls this one, then that function will also be skipped because of under approximation. However, in many cases, if you look at these functions, or like you analyze them dynamically, they just do some very basic thing, and what we do is we have the dynamic analysis augmented with tracing in Erlang. So when we run some test cases, we can record for each function what was the input and what was the output. And for Erlang, these are mostly pure functions, so we can record the fact that, for example, if you call foo with argument 2, then it returns false. And then we can collect a bunch of these data points, and we use them as summaries for those kind of functions where you don't have any summary at all. And this interplays pretty nicely, because the data that we get from the dynamic analysis is essentially under approximate, because we just have certain, we know what the function does at certain data points, and we can use these basically as disjuncts, and it fits well into the under approximate nature of Infer. But yeah, I'm happy to expand on that.
Yeah, I'd love to learn more about that. That sounds, I want to try that out now.
Yeah, I think, although we have to note that I guess it probably works well because Erlang is pure, so you don't have side effects. If you do, then I guess when you are doing this tracing, you also have to consider the side effects. So like when you call a function, it's not only the arguments, you have to consider the state. And when it returns something, you also have to consider how it changes the state. So it might be a bit complicated with non-pure functions. But yeah, I will also be on Discord, so we can discuss this further.
Yeah, would love to read more. And yeah, so interesting though. But essentially, you're saying for these methods for which you know nothing, the idea is like you're essentially using a sampling approach. You're essentially sampling it so that you can kind of get some kind of approximate sampling of the behavior in the absence of
exactly.
not knowing it, when otherwise you'd know nothing.
Exactly, that is correct. Yeah. And then, you know, how good your sampling is, it will depend on how good and how elaborate your dynamic analysis is. And at WhatsApp, we actually have a paper published about the dynamic analysis last year at ICST. It's called FOSTA, Fully Automated Server Testing. I can also put a link to that paper because that is essentially the dynamic method that feeds us the data that we are using later.
Interesting. Yeah, I wonder even, I mean, since, okay, I mean, this may be stretching it a bit, but I also wonder, for example, if you don't have dynamic, if you're trying to live strictly within the static space, I do wonder whether you can even just essentially maybe pre-process, if you have access to the code, I wonder if you can pre-process the code or even throw the code into an LLM with, let's say, like, with the right prompt saying like, oh, with the, like, can you summarize the behavior of this method in some way to kind of get that, to achieve that approximate purely statically. But that's just, yeah, an idea that I thought of when hearing you.
Yeah, it's an interesting one. Okay, any other questions? Yeah, nothing on Discord, nothing in the room. So thanks again, Matthew, for the nice talk.
Thank you.